Welcome to the calculus supplement for our question number 10 of trigonometry worked examples. So in this video we are going to do top the walk calculus. Okay, now before we proceed, I would like to show you the graph of our force F. That is the graph of the equation F equals capital A multiplied by cos bt minus A cos 3bt. We have seen this graph before. I am going to show it to you again, and I am going to show the graph in the interval minus pi by 2 to plus pi by 2. And here it is. This is the graph. If you look at the graph, the force is 0 at minus pi by 2. It increases to a local maximum, then decreases to a minimum, then again increases to the maximum, and again goes back to 0. Correct? And this is the graph for capital A equals 1 and small a equals 1 divided by 3. If you look at this graph, the minimum point corresponds to BD equals 0 and the two maximum points correspond to BD equals minus pi by 4 and BD equals plus pi by 4. Therefore, plus pi by 4 and minus pi by 4 are the maximum points and BD equals 0 is the minimum point. But how do you do the calculation without resorting to this graph? That's what we are going to see in this video now. Before we proceed, I am going to give you a very crude introduction to how to calculate maximum and minimum points. It's going to be a very crude introduction. I am not going to prove anything. I am only going to list out the method that is used for the calculation. Let's say we have a function y equals f of x. To start with, you take the first derivative. At maximum and minimum points, the first derivative will be equal to 0. That is, the slope of the function will be 0 at maximum and minimum points. I am not going to prove you anything. We will have a detailed discussion of maximum, minimum, functions, limits, derivatives, integrals, antiderivatives in our calculus videos. This is just to calculate the maximum, minimum points for this function, that's all. So dy by dx, the slope of the function is 0 at maximum, minimum points. Then you will get an equation. You have to solve. You will get a set of solutions. Then you take the second derivative, that is d square y by dx square. Now, at the points where d square y by dx square is negative, that is, you apply the solutions to the second derivative, and if it is negative, then the point is maximum. And when you apply the solutions here, if the second derivative is positive, that point is a minimum point. Remember that the function can have multiple maxima, multiple minima. Then you can find the local maxima, minima within a certain interval that you can do. Or the function might have only one global maximum, one global minimum. Or the function may not have any maxima, any minima. All the three are possible. Okay, you should have that in mind. So with this in mind, let's go to the main calculations. So here are the calculations. Our function f equals a multiplied by cos bt minus a cos 3bt. I am going to differentiate f with respect to bt. But instead of writing df by dbt, I am going to write bt as some x. Let me call this as x. Okay, just to simplify things. So, f equals a multiplied by cos x minus small a is 1 divided by 3 cos 3x. Okay, now let us take the first derivative, that is df by dx. A being a constant doesn't bother us. Now cos x, the derivative of cos x is minus sin x. Then the derivative of cos 3x is minus sin 3x. Don't forget the chain rule, multiplied by 3. Multiplied by the derivative of 3x. Derivative of 3x is just 3. Okay? So this simplifies to a multiplied by, you have minus of minus plus, you have this 3 and this 3 will be cancelled. Right? So you have sin 3x minus sin x. And we have to set df by dx equals 0 and solve for x. Which implies, since a is not equal to 0, as per definition a is not equal to 0, therefore we can write sin 3x minus sin x equals 0. Okay, now we already know the solution for this. The solutions are x equals 0 and plus or minus pi by 4. Okay, now let us take the second derivative. So d square f by dx square. So df by dx is sin 3x minus sin x. Sin 3x. The derivative of sin is cos. Therefore, this would be cos 3x multiplied by 3. Minus sin x is cos x. Derivative of sin x is cos x. Okay, so this will give me 3 times cos 3x minus cos x. Okay, now first let us apply x equals 0. D squared f divided by dx squared and x equals 0. So you have 3 cos 0, cos 0 is 1. So 3 minus 1. So it is 3 minus 1 equals 2, which is positive. Therefore, f is minimum at x equals pt equals 0. Next, let us apply x equals plus or minus pi by 4. I done a space, I won't just rub this 4, okay? Okay, so we have to apply x equals pi by 4 here. So cos 3 multiplied by pi by 4. Cos 3 pi by 4. Then cos x, that is cos pi by 4. Cos 3 pi by 4 is negative 1 divided by square root of 2. Minus cos pi by 4 is 1 divided by square root of 2. This is clearly negative. So, okay, now let us go to plus. That is d square f by dx square at x equals minus pi by 4. So we will have cos minus 3 pi by 4 minus cos minus pi by 4. Remember, cos of minus x is nothing but cos x. Therefore, this two will be equal because cos minus 3 pi by 4 is equal to cos 3 pi by 4. Similarly, cos of minus pi by 4 equals cos pi by 4. So this will also give you the same. Therefore, at x equals plus or minus pi by 4, d square f by dx square is negative. Therefore, at x equals plus or minus pi by 4, the function f is at maximum. Okay, so in the graph which you had seen earlier, the maximum points were at minus pi by 4 and pi by 4, and the minimum point was at 0. So that's the calculation of maximum minimum points for our question number 10 of trigonometry. Thanks for watching.